Assalamu alaikum. I am Rayyan from the first group. Me and my friends are going to do the video presentation for communication system assignment. Okay, first of all, I want to remind to all my friends to stay at home. Okay, me and my friends Ahmed and Rayyan, which is me, and Ahmed Bamatrif and Abdul Majid are going to explain the first chapter. Okay, the first chapter contains two parts. The first part will do me and Ahmed Al-Hatami, and for the second part, Ahmed Bamatrif and Abdul Majid are going to do it. Okay, here is the main topics for our presentation. This is slides, me and Ahmed. Okay, the basic communication module contains three main components. The first one is the source, second is the channel, and third is the sink. Okay, the source is the sender, which is our first place. We are going to send the information from it to our destination. And in the middle we have the channel. The channel is the transmission path that going to modulate our signal and do some operation and then send it to our sink, our destination. And the third one is our second place that going to receive our signal. For the communication system module, which the full one has sender, modulator, transmitter, and the channel, receiver, demodulator, and reception. Okay, for the sender, which is our source, that our information are going to start from there, then go to the modulator. The modulator is act as an amplifier that's going to amplify our signal, then send it to the transmitter, then to the channel. After that, get to our receiver. Then remember, and second step, we modulate this, the signal, we amplify it. So now we are going to get the first, the original one, and we are going to demodulate it. Then we go to our destination. Okay, for the communication mode type, we have we divided into three main types. The first one, which is a simplex system, and also a half duplex system, and also we have a full duplex system. The difference between all of these three types: for the simplex system, we have three main components, which is transmitter and receiver, sender and receiver, and it only contains one direction, so we can only send our information from place 1 to place 2. And for the half duplex system, we can send from the place 1 to place 2, and from place 2, the second one, to the place 1, because we have two sender and two receiver at both places. So but only we can send one signal at the time. But in the full duplex system, we can send from the first place to the second, and from the second to the first at the same time, because we have two directions. And from here, my friends are going to continue. Thank you.
Assalamu alaikum. My name is Ahmed Al-Hattami. I will continue to explain this part of this chapter, and I will explain in the beginning about power measurement. And as we know, we have three types of power: decibel power, and dBm power, and bell power. For the decibel power is used to measure the ratio between two values. Value to the measured relative to the reference value. So we need to measure P1 to the reference P2. So it also used to express the ratio of voltage and current in communication. So by this relationship, we get the difference between P1 to P2. Okay, if the answer of this equation comes in positive value, that's mean the P out is greater than P input, which means the device has power gain or amplification. On the other hand, if the answer comes in negative value, we can say that the P out is less than the P input. So we can say the device that has powerless or attention. If the P out equal to the P input, so the power gain is 1 or 0, and there is no dB. The dB will come by 0. So the second type of power is dBm. dBm is the same of dB, but the difference is only in dB we have variable reference P2, but in dBm we have fixed reference and is 1 milliwatt. The last type of power is Bell, and Bell is 1/10 of decibel. So we just change the equation, we divide it by 10, and the 10 in this equation will pass with the 10. We pass it, we divide it, and the equation will come like this. The second subtopic in this chapter is about electromagnetic frequency spectrum. Communicating information between two locations is done by converting the original information to the electromagnetic energy and pass it to the receiver. Before the receiver gets the information, the device convert the information back to its original information. The electromagnetic energy is distributed throughout infinity range of frequencies. The spectrum is divided into bands, with each band have a different name and boundary. And we have a real question, what's FM and AM? When you see the FM and AM at the morning in the radio, so what's the difference between them? In simple word, the difference is just in the range. The range of the FM is between 88 and 108 megahertz, and the range of the AM is between 535 and 1605 kilohertz. So the difference between all this is just by the frequencies range. Now I'm going to explain about wavelength. Wavelength is a length that one circle of electromagnetic wave occurs in space. So we said that the frequency come in half circle in a positive and half circle in a negative side. So we have wavelength. The wavelength is when the all circle has done in respect to time. So that's wavelength. Wavelength, it's come by this equation, and the symbol is mean wavelength, and the unit is m. C is the velocity of light, and it's a fixed number. You don't need to explain it, you don't need to get it, because it's international fixed number. 3 multiply 10 to the power 8, sorry for this mistake, and the unit is m over s, and f is the frequency. We are familiar with it. Now we have a communication bandwidth. Bandwidth of internet and information signal is a difference between the highest and lowest frequency in that signal. So we have every signal get frequencies. Frequency, as we said, is half of it in the positive and half of it in a negative. So we have highest value and lowest value. So the bandwidth is just a difference between them, between the highest and the bandwidth. So the bandwidth of communication channel must be equal or greater than the bandwidth of the information. So if we have device and we have also sender device and we have receive device and we have channel, that's the simple communication system. The bandwidth of a channel should be equal or more than the bandwidth of the information, because if it's small, the information will not pass. And finally, we have the last subtopic of part 1, chapter 1. We have information capacity. Information capacity is a measure of how much information can be propagated through a communication system. So if we have sender and we have receiver and we have also channel, how much information will pass? So
Assalamu alaikum, I am Abdul Majid, and one of my friend and me, we are going to explain chapter 1 part 2, which consists noise, representation, types, source, noise parameters. The definition: any undesirable electrical energy that falls within the passband of the signal. Noise have two categories: correlated noise, which exists only when a signal is present, and uncorrelated noise that present all the time whether there is noise or not. And the uncorrelated noise have external and internal noise. External noise that generate outside the device or circuit. Atmospheric noise, naturally occurring electrical disturbance that originated within Earth's atmosphere, such as lightning. Extraterrestrial noise consists of electrical signal that originate from outside Earth's atmosphere and therefore also known as deep space noise. Man-made noise, noise that is produced by mankind. Source, spark producing mechanism like AC power generating, switching equipment. And the internal noise, noise that generated within the device or circuit, like shot noise caused by the random arrival of a carrier's holes and electrons at the output element of an electronic device. Transit time noise, irregular random variation due to any modification to stream of carriers as they pass from the input to the output of a device. Thermal and random noise, it is associated within the rapid movement of electron within a conductor due to thermal disturbance. To find noise power, you have to use this equation.
My name is Ahmed Badr, and today I'm going to complete this chapter with Abdul Majid. My part actually to explain the correlated noise and its types, and also the noise parameter. So let's start with the correlated noise. Actually, there are two types of correlated noise. These types are harmonic distortion. So the harmonic distortion occurs when unwanted harmonic of signal are produced through nonlinear amplification. Harmonic are integer multiples of the original signal. The original signal is the first harmonic, fundamental harmonic, and frequency 2 times the fundamental frequency is the second harmonic, 3 times is the third harmonic, and so on. So let's look to the graph or to the plot. So this is the blue frequency is the fundamental harmonic. Fundamental harmonic, that is the input, for example. Fundamental harmonic. So let's look to the other harmonic, which is H1, H2, H3, this one. So this is actually the harmonic, the second harmonic, third harmonic, fourth harmonic, and so on. So H1, for example, is the fundamental harmonic multiplied with the frequency of 2, or like this. Okay, this is actually the harmonic distortion. Well, correlated noise actually also has intermodulation distortion. So intermodulation distortion is the generation of unwanted sum and difference frequencies produced when two or more signals mixed in a nonlinear device cross product. So the difference between intermodulation distortion and harmonic distortion, the input signal for intermodulation distortion is two input signal, but in harmonic distortion we have only one input signal. So in this intermodulation distortion, actually the distortion occur when because of the sum or difference between these two input, like for example f1 and f2 is the two input. Okay, and look for f1 minus f2, f2 minus f1, actually this is the difference between them. For example, f1 plus f2, this is the sum of the input and the two input signal. So the other part is noise parameter. Noise parameter. We have 3 noise parameter in this chapter. The first one is signal to noise power ratio, which is the ratio of the signal power level to noise power level, and can be expressed as S over n, which is equal to PS over Pn. Okay. Actually, the greater the signal to noise power ratio, the better. You know. And for noise factor is the ratio of the input signal to noise ratio, the output signal to noise ratio, which can be expressed as F equal to Sn over signal to noise output, which is signal to noise input over signal to noise output. And last one, which is the noise figure, is the noise factor stated in dB and parameter to indicate the quality of receiver. Okay, the noise factor actually it is same with the noise factor. Noise figure is the same with the noise factor, but the difference in the noise figure is expressed in dB. And this is the expression to find the noise figure, which is 10 log f, which is the noise factor. So until here we finished our chapter. We hope that you enjoy, and we increase your knowledge about noise and its types.